Okay, good morning class. Right, so Weekend, who is still not here?
Two more is not here. Uh, Avinash and Farah.
Oh, okay. Okay, so please click the link and enter the code.
Teacher,
Yeah.
for Avinash presentation?
Avinash is continue next week.
Oh, okay.
Okay. Did Farah and Avinash join the class before?
Yes. Teacher, the presentation continue tomorrow, right? Extra class.
Oh yeah, so sure. If you want to continue it tomorrow, so we can. Only two more, right? You and Avinash, right?
Half of mine and Avinash. So yeah.
Okay. So we continue tomorrow. Then after that, we continue our lesson.
Okay.
Okay. Can someone please text Avinash and also Farah? I already called them in the group. Okay, so let's so here should be like 14. So who's another two is still not join the class point? Hmm. Lakshmi is here, Sharanya, Kritika, Indra, Alpin. Asha? Where is Asha? Okay, Asha and Nirupa. Asha? Okay, Farah is here, so only Avinash. Avinash also already here. Okay, so all of you already here. So for those who just join, please enter the code and also click the link. Where is Asha? Asha, still waiting for Asha and Farah, and another one is Avinash. Okay, so just let's start first. Okay, I already text Asha. Okay, so actually we stop until reflection, right? So reflection, and we stop until the exercise for the reflection. Okay, sorry, refraction. Okay, so let's try to answer this one first. Okay, so it says here, which of the following shows the effect of wave when the water wave is moved from a deep region to shallow region? So you have to know what happened with the wavelength. Okay, when it enter the deep region to shallow region. Okay, four more. Trisha, Nirupa, Avinash. So which of the following shows the effect of the wave when water wave move in deep region to a shallow region? If you're having a problem to submit the answer, okay, you can just write your answer in the chat. Okay, Nirupa? Okay. Okay, so here is it when the water wave move from deep region to shallow region, okay, so mean there is a change in the depth of water. So the depth of water will become decreased. So this is the refraction, right? So at the deep water, the wavelength is higher. Okay, if we compare to the shallow. Okay, so the shallow one, the wavelength is much closer. Okay, so and about the speed, so V is equals to F lambda. So if the lambda is decreasing, the speed also will decrease. Okay, so here when you move from deep to region, okay, to deep region to the shallow region, so the wavelength will be decreased. Okay, so the wavelength will be decreased. So when the wavelength decrease, the speed also decrease. Okay, so decrease, but the frequency is constant, right? So that is for the refraction. Okay, for the refraction, the speed, the wavelength, okay, it will change, okay, and but the frequency will be the same. Okay, so this one is actually the answer is C. Okay, why so many people answer A? Is increase. Oh, you already forgot, right? Okay, for number 2. So this one you have to wait. I changed the A, B, C, D first. Okay, this one you have to calculate A, B, C, D. So what's the formula for this one? For the refraction of wave. Okay, I put the formula. Okay, I already give the formula. Okay, so who still didn't answer this question? Trisha, Janet, Tava. Okay, so this one they use the formula V over lambda 1. V1 over lambda 1 is equals to V2 over lambda 2. Okay, so the question said the speed, if the speed of the water wave is 5 centimeter per second in the region of deep of water, the region of deep water. So this one, the speed is 5 centimeter per second. So you have to calculate the speed of water wave in the region of the shallow water. So mean you have to calculate the speed of water at here. Okay, so we use the formula V1 over lambda 1. I thought, oh, the answer is B. Okay, so V1 is actually 5 and the lambda 1 is 3. So this is for the deep water. And for the shallow water, okay, the V2 you need to find. The lambda 2 is 1.5. So you just cross multiply, you will get 7.5 is equals to 3 V2. So V2 is 7.5 divided by 3, you will get 2.5. So the answer should be B, boy. Oh, you got B. So why are you got some of you got A and D? How do you got A and D? What formula did you use? Can you understand for those who got wrong for this question? Can you understand why I got the answer B, boy? Nirupa, Abi, Farah, Tava. Okay. So the next one, the diagram shows the pattern of water approaching a shoreline. So which is the most suitable location for a child to swim? Which part of the water that is suitable for the child to swim? Where is the part of the water that is more calm? Okay, one more. Who is it? Asha? Teacher, I put salah. I want to put C but typo A. Okay. Where is Asha? I give 10 seconds more. Alright, so for this one, so the answer should be C here. Okay, because, right, we already discussed about this one. This one is just like the concave lens, right? So the concave shape. So concave shape, they usually will spread out the energy. Okay, they will spread out the energy. Okay, they spread out the wave, right? So the energy also will be spread out. So means the energy will be decreased, the amplitude will be decreased. So this one, this is the part where the water is more calm. Okay, and for this one, it's a shape like the convex. So convex, they usually will converge all the energy to the one point. So means the energy will be high. So the answer should be C. We can you change your answer to C, right?
Yes, sir.
How about B? Okay, very good. Okay, for this one, you have to choose which of the following wave pattern can be seen on the screen. So there is a part that the water is deep and there is the part that the water is shallow. Okay, 3 more. Salahnya, Saji, Fasha. Where is Ashu? This guy, huh? Okay, so here the water is shallow. This one the water is deep. So here, of course, the wavelength will be decreased, and this one should be increased. So the answer is A. Okay, so yes, correct. Farah, what happened today? Okay, and this one for number 6. So which pattern of the wave fronts will be observed in the basin? Okay, Avinash. Avinash. Where is Avinash? Are they sleeping or what?
I'm not sure, Chair.
Maybe I should put in the parents group. Okay, never mind. Wait for a moment. Okay, so let's check your answer. For this one, the water is deep okay, we compare to at this part, right? So here means the wavelength is longer. Okay, and this part the wavelength should be shorter. So the answer should be 8. Okay, A. Right, very good. Okay, then this is the last one, I think. Okay, Janet. Now Janet is missing. Okay. All right. Okay, so for this one, the answer should be D, donkey. Okay, so this one, the shallow area, okay, the wavelength should be shorter if we compare with the deep area. And you have to know that this is acting like a convex lens, so all the wave will be converged into one point. So later you will see they will focus at one point here. So this one we call as the focus point. Okay, so the answer is D, donkey. All right. The next one is, okay, so what's the answer for this one? Which wave pattern is observed when the wave pass through the perspex block?
Teacher, it doesn't state there from shallow to deep, right?
Yeah, but actually when you put the perspex blocks in the ripple tank, so at that part you put the perspex block, the water will become shallow.
Okay, sure.
Is it three more? Sharanya and Eugene. Okay. Alright, so what's the answer for this one? So here, this is the acting like the concave lens. So we already know concave lens, the wave will be spread out like that. Okay, and the part where they put the perspex block, okay, so the depth of the water will become shallow. Okay, so the answer should be B, boy. Okay, so now we move on to the new, actually you can see there is a structure question, right? On your notes. Okay, so that one will become your homework, okay, for this week. Okay, and I want you to answer in the test pad, okay, and then change the format to PDF and turn in. Okay, I already assigned for you the assignment, so you can just submit all the answer, okay, at the GC. Okay, so that one is your homework for the structure. Is the homework for this week. Okay, and then we go to the next one. So this is the third phenomenon of wave. Okay, so there are four actually. The first one is the reflection that we already learned. Okay, and refraction. Okay, and the third one is the diffraction, and the last one is the interference. Okay, so here it says diagram below shows two walls which are built near the shore. So you have to compare the pattern of water wave before and after passing the gap between the two walls. So what is the function of the wall? So here you can see when before it passed through the slit, okay, it passed through the slit or the gap, so it is in the plane shape, right? So when you pass through the slit or the gap here, right, so it will become circular. Okay, so it will become circular. So it means here the wave is spreading out. So here the waving is spreading out to the bigger area. So we already know when the wave is spread out like that, of course the energy will be decreased because of the amplitude also will be decreased because the amplitude is actually represent the energy. So when it enter the gap, okay, the wave will be spread out. So at the same time, the amplitude also will be spread out, and the energy also will be spread out at the same time. Okay. All right. So this is actually also the example of the diffraction. Okay, so let's see the video here. Okay, so you can see the wave enter the slit here. Okay, then it will form like the circular wave here. Okay, so that the wave will be spread out and also the energy and the amplitude also will be decreased at the same time. So this is the example of the diffraction. Okay, so what does it mean by the, sorry teacher got disconnected. Okay. So what is the diffraction of wave? So diffraction of wave is a phenomenon in which wave is spread out, okay, or bent as they pass through a gap or around a small obstacle. So it's a spread out of the wave when they pass through a gap or maybe they pass through the obstacle. So let's say if I have an obstacle here, so this is the water wave, right? So after it passed through the obstacle, so it will be like this. Okay. So means the wave is spread out also. Okay, and will be bend, okay, after it passed through the obstacle. Okay, so this is the meaning of the diffraction. Okay, it's a spread out. The water wave spread out or bend. So bend is like this. Okay, so this is called a bend. All right, so the next one is, let's see the video here.
When the gap size is approximately equal to the wavelength, the wave pattern after passing through the gap is circular. When the gap size is bigger than the wavelength, the wave pattern after passing through the gap is less circular. The wave
So if the wavelength, okay, if the wavelength of that pass through the gap, okay, is almost same size as the gap, same size as the gap. So you can see the wave pattern here. Okay, so it will move. It will be like a circular, like this, circular wave. But let's say if the gap is more bigger than the wavelength, so you can see the wave pattern will be like this. Okay, it will be like bend a little like this. Okay, at the edge of it. All right, so that is the diffraction. Okay, so observe the water wave when they meet a barrier. So that one, the first one we see when it pass through the slit or a gap. So this one, they say they meet a barrier or the obstacle. So what will happen here?
observe the waves when they meet a barrier. What happens if the length of the barrier is larger than the wavelength? The waves bend around the edges and fill up the space behind the barrier. A shadow area is formed behind the barrier. When the size of the barrier is smaller or approximately the size of the wavelength, the diffraction pattern of the waves is more obvious. When the size of the barrier is larger, the shadow area is larger. The diffraction pattern of the waves is less obvious.
Okay, so here, when the size of the barrier is small, okay, so means the diffraction, okay, the effect of diffraction will become more obvious. So if you increase the size of the barrier, okay, so the effect of the diffraction will be less obvious. Okay, so this is to study the characteristic of diffracted wave in the ripple tank. Okay, so this one, if you have a chance to go to school, so we will do this experiment, including for the refraction, diffraction, and also interference. Okay, so this is the experiment for the ripple tank for the diffraction of water wave. Right, so let's see. Okay, so here they produce a plane wave here. So when it entered the slit, you can see it produced the circular wave. Okay, produce the circular wave. Okay, so that is the diffraction. Okay, now we have to draw. Okay, so we have to draw the diffraction of wave when it pass through the white gap. Okay, so what you have to do, the first one, you have to draw this line. Okay, and this one, because it's a white gap, right? So the wave that will be formed after the diffraction is not in the circular, okay, but it should be like a bend at the edge of the wavelength. Okay, and another thing, the wavelength should be same before and after the diffraction. Okay, so you have, let's say, just do you have just estimate, right? So this is the wavelength, so means after it being diffract also the wavelength should be same. Okay, so this is when it pass through the wide gap. So what happened when it pass through the narrow gap? So when the narrow gap, it will produce the circular wave. So you just draw, but again the wavelength should be same before and after it being diffract. Okay, and then the next one is the small barrier. Okay, for the small barrier, what you have to do, you have to draw this line first. Okay, and then you draw the line, okay, the wavelength. Because after this, you need to draw for me and make sure the wavelength is same before and after the wavelength. Okay, before and after the wavelength. Okay, and this one is like this. Okay. So this is how you draw for the diffraction of wave when it pass through the gap and also the barrier. So what you have to do after this, you have to draw for me. Okay. So later you have to draw for me. So here it says compare the wavelength of the wave before and before and after passing the gap. So I already mentioned the wavelength should be same before and after. Okay. And what can you say about the direction of water wave after passing through the gap? So here you can see the direction is just spread out, right? So the wave is being spread out like that. So it say it will be spread out, and this one also it will be spread out. But as you can see here at the small gap, the water wave is more spread out if we compare with the bigger gap here, right? Okay, now you have to draw for me when you pass through the narrow gap and also the wide gap.
Teacher,
Yes?
can send the class point link again because I just left.
Oh, okay. Wait for a moment. 3898. Okay.
Thank you, teacher.
All right, welcome. Okay. Sure, when I submit, it get resettled. How future? Uh, you cannot submit it anymore, is it? Never mind. Because once you already submit, cannot you cannot make a correction, so never mind.
Teacher, so hard to do.
To draw. It's okay. Just draw means like as long I know it's a circular and I know it's a the edge of the wavelength is bent, okay, and the wavelength is almost the same, it's okay. I understand it's hard for you to draw if you're using your mouse. Just do what you think is the best that you can do. It's okay. Wait for a moment. Hello? Ada? Dia ajar kata 5. Okay.
Teacher, I think you can remove the other one of mine.
This one, is it? We can.
Yes.
Okay. Uh, the last one, right?
Yes, sure.
Okay.
Thanks, sure.
Okay. Right, so I give you 1 more minute, so then I will just close.
Teacher,
Hmm?
I submitted it.
Already submit. Tava, is it?
Yes, it's loading.
Oh, okay, okay, okay. So only Q3. Okay, so I just close. All right. So for this one, you have to draw the line here. So this is a small gap, right? So it should be circular wave and the wavelength should be same, okay, as the before it being diffracted. And this one also, okay, but this one is not circular. Okay, it will be like a bend at the edge there. So it should be like this. Okay. All right. But make sure when in exam you draw the wavelength is same, okay, before and after. Oh, Avinash, you didn't finish it yet, right? Hmm. Hmm. Okay, very good. Okay, now you have to draw when you pass through the barrier. Okay. Teacher, can please delete the name without caps?
Teacher, after this.
Oh, yeah. Without caps is... Okay, 1 more minute. Okay, Abi, Janet. Okay. So, close. Okay, for this one is pass through the barrier, right? Okay. So you pass through the barrier. So what you have to do, you have to draw the line like this first. Okay, and then the line should be like this. Okay, so this is for the small barrier. Oh, okay. So for this one, you have to draw like this first, and then, okay. Right. So that's how you draw. So let's check. Oh, wrong. Should be like this. This one, if you pass through the gap, a gap. A gap we draw like this. But this one, when you pass through a barrier, it should be like this. Okay. So this one is wrong. This one is right. Eugene, this is wrong. I did not know how to draw. Then I already teach you this now. Can you draw now? Oh, okay. Right, very good, Kritika, Trisha. Avinash, why it suddenly become circular wave here? Papa is wrong. Okay, Abi. Okay, so let's move to the next one. It says state the change to the incident wave that occur after passing the gap. So this one for the diffraction, okay, the speed, the wavelength, and also the frequency, okay, it will not change, okay, before and after it being diffract. So it will be same, okay, only the amplitude, okay, while the direction of the wave, it will be spread out, okay. So the frequency will be same before and after it pass through the gap, a barrier, okay, and another one for the wavelength also will be same, and the speed also same, but the direction of wave will be spread out and the amplitude will be decreased. So the amplitude is actually represent the energy, okay, the energy of the wave. Okay, why the amplitude of the diffracted wave decrease? Okay, so because the diffracted wave, they're spreading the wave, okay, to the wider area. So when it spread the wave to the wider area, so the energy of the wave also will be reduced. So the amplitude will be decreased. Alright, so the next one, you have to study the factor which influence the diffraction of water wave. Okay, so now we study about the size of slit. So the size of slit for the small gap, okay, it can form the circular wave. This one is for the small gap, right? For the small gap, it will produce the circular wave. Okay, while the bigger gap, they produce the plane and bend at the edge here. Okay, so what we can say here, for the small gap, the diffraction will be more obvious if we compare with the bigger gap. Okay, so the smaller the gap, okay, the more obvious the diffraction. And for the barrier, okay, for the barrier, the small space behind the barrier, while at the bigger barrier, it will produce the bigger space, right, behind the barrier. So for the small barrier, the diffraction is become more obvious, okay, while the bigger barrier, the diffraction will become less obvious. So means the smaller the barrier, the higher the effect of the diffraction, the more obvious the diffraction. Okay, so what is the relationship between the shapes of diffracted wave with the size of the gap? Okay, so the smaller the gap, the more circular the diffracted wave. Okay, and for this one, we compare the wavelength. Okay, so you see the gap here, they have the same size of gap, but they use a different wavelength. So this one, they use a small wavelength. This one, they use a bigger wavelength. So what you can see when you use the small wavelength, okay, the diffraction is less obvious. But when you increase the wavelength, okay, when you increase the wavelength, you can see the wave become circular. So means the diffraction become more obvious. Okay, so will be plane and bend at the edge, and this one will be form the circular wave, and this one the diffraction is obvious. So what is the relationship between the shapes of diffracted wave with the size of the wavelength? So here, the longer the wavelength, the more circular of diffracted wave. So there are two factors, okay, that make the diffraction more obvious. The first one is the size of gap. Okay, the smaller the size of the gap, the more obvious the diffraction. Okay, so you can see here, this one they produce the more circular wavelength, and this one is only the bend at the edge of the wavelength. Okay, so and for the wavelength, if you use the higher wavelength, you can see the wavelength here is more circular. So means the diffraction will be more obvious. Okay, so there are two factors. The first one is the size of gap or size of barrier. For the barrier, the smaller the barrier, the more obvious the diffraction. While the wavelength, the higher the wavelength, okay, the more obvious the diffraction. Okay, so this is actually the summarize. Okay, so the effect of diffraction of wave, they say we use the fixed wavelength, okay, but we change the size of the gap. So for the wide gap, okay, the diffraction less obvious, okay. With the small gap, the diffraction more obvious because it's produced the circular wave, okay. So and then the second one, we use the fixed size of slit. So we use the same size of slit, okay, and then we change the wavelength. So if you choose the short wavelength, the diffraction will be less obvious. But if you use the long wavelength, the diffraction will be more obvious. Why? Because we can see the circular wave is formed here. Okay. Yeah, they want this one. Yeah, I understand. Some of you don't have this. 4M also don't have this one. This one I will give you later when the class finish. I will put in the group. Okay. Yeah, 4M also don't have. Okay, so that one is for wave, right? For the water wave. Okay, so we already learned diffraction for the water wave. Now we learn for the diffraction of sound wave. Okay, so for the sound wave here, it says the audible sound wave have wavelength in the range of 1.5 cm to 15 meter. Okay, so that is the wavelength for sound wave. Okay, while the light wave only have 4 to 7 times, okay, 7 times 10 power of negative 7. So mean it's much smaller than the sound wave. So a radio is placed nearby corner of a wall. So the radio is turned on. Okay. And the first one, he said you have to compare the wavelength between the sound wave and the light wave. So for the sound wave, it's already stated there, it starts from 1.5 cm until 15 meter, right? While the light wave is 4 until 7 times 10 power of negative 7. So means the sound wave has the higher wavelength. Okay, can you see the radio? So what inference you can make about the diffraction of light wave? Okay, so now we go back to the formula. Okay, formula for wave that is V is equals to F lambda. So F is equals to V over lambda, right? So we compare the lambda here, all right? So we compare the lambda here. If the lambda is smaller, okay, we already learned there are two effects that affect the diffraction, right? First one is the wavelength and the second one is the size of slit or size of barrier. So if you want to make the diffraction more obvious, you have to increase the wavelength. Okay, so but if you compare this wavelength between sound wave and the light wave, there is very much difference. Okay, the sound wave is much bigger than the light wave. So means the sound wave is more diffracted than the light wave. So that's why you cannot see the radio, okay, because the light wave, okay, is hard to diffract it because of the wavelength. The wavelength is too small, okay, for it to be diffracted. So you cannot see the radio because light is difficult to be diffracted. This is due to the wavelength. The wavelength is too small, okay. While you can hear the sound, yes, you can hear the sound because sound can be diffracted because the wavelength is much bigger. And you already know that two effects that affect the diffraction, whether it's less obvious or more obvious, is the wavelength and the size of the slit or the barrier. So the higher the wavelength, okay, the higher the wavelength, the more obvious will be the diffraction. Okay, so now it sees the light has the less wavelength, so it will be less diffracted, and actually it's hard to diffract, okay, because the wavelength is too small. Okay, now you have to relate the wavelength with the effect of diffraction in order to explain why we can hear the sound of radio placed nearby a corner of a wall, but we cannot see the radio. So this is the reason the sound waves are more easily diffracted because its wavelength is longer than the wavelength of the light. Okay, so you just refer back to the two factors that affect of the diffraction, the wavelength and also the size of the slit or the size of the gap. Okay, so far can you understand about the diffraction? Do you have any questions before I go to the light?
No, teacher.
No. Okay, now we already know the sound, diffraction of the sound, diffraction of the water wave. So we move on to the light wave. Okay, so the light wave is actually, we use a laser. Okay, we use a laser, then you make it pass through the single slit. Okay, then you see what happened to the slit. To this. What happened to the screen? What the image of the screen that we form? Okay. So let's see this video.
This is a demonstration of single slit diffraction. When a laser beam, I'm putting my hand in the beam here. This laser beam is incident on this circular dial that allows me to dial in the width of a slit through which the laser beam passes.
So they use the green laser.
This slit of various widths that I'll show you, and then having passed through the vertical slits, produces a pattern on the screen here. So
okay. So this is actually when you use a laser and we pass through the slit. Okay. So that will produce the fringes, the dark fringes, and also the bright fringes here. So, but at the middle there, okay, at the middle you can see the bright fringes. Okay, is quite white. Okay, if we compare quite white and quite bright. Okay, if you compare with other bright fringes. Okay, so what I want you to focus is actually at the center here. What will happen to the bright fringes? Whether it become wider when you increase the slit, okay, the size of the slit, or we become smaller. Okay, so let's see, continue. Okay.
The width and what you see in this pattern is a central bright spot and then dimmer spots to either side. This is called the M equals 0 maximum, the M equals 1 on either side of that, M equals 2, etc. With a constructive or destructive interference, namely a dark spot at the edge of each bright spot. So this is for a slit width of 0.02 millimeters.
Okay, so now using the size of slit is 0.02 millimeter. Okay.
If we move to 0.04 millimeters, what?
Okay, so now it moved to 0.04, means it increased the size of the slit. Okay, so if we compare, this is 0.04. Okay, so let's say if we compare just now, like we see, this is 0.02, right? And this is 0.04. So what is the difference here? Okay, the size of the fringes there, okay, the size of the bright fringes there is become smaller, right? It's become smaller, and you can see there is more dark and bright fringes, right? That can be seen on the screen. Okay, it's like they compress it. Okay, they compress it. Okay,
0.04 millimeters, what you see is a pattern that's tighter with bright spots that are less wide. So as we increase the slit width, this is 0.08, the pattern gets even tighter.
Okay, so 0.08, you can see they become more smaller, and there is more bright and dark fringes that can be seen in the screen.
Or 0 point, and it's very, very tight. We can also do the same with circular apertures.
Okay, so this is what happened when you make the laser, okay, the light pass through the circular aperture. So you can see here it produce, like in the middle here, they will produce the bright, okay, the bright white color, okay, in the middle here. Okay,
So this is a circular, instead of being a slit through which the laser beam is pointed, this is a circular aperture. The laser beam is incident on a hole and blocked from passing outside the hole and only goes through that hole. And what you see here is a pattern with a central bright spot in the middle, but then rings around it that are reminiscent of the dots that appeared in the single slit pattern.
Okay, so
This is a
that is
very
actually
important
the
pattern.
refraction of light. Okay, so we continue. Okay, so for this one, okay, so let's see for this one, this video. So single slit diffraction. They use the red laser. Okay, so this is the slit. Okay, they can change the width of the slit. Okay, so they change the width of the slit here. Okay, so the slit width increasing. Okay, so when it increase, so you can see the middle here, it becomes smaller, and also the number of fringes also become higher. So there you can see more fringes in the one screen. Okay, so now when the slit width is decreasing, so you can see the size of the fringes in the middle also become increase. Okay, so this one is a pinhole, just same like this. Just now that we see the round hole, right? So it's the same. Okay. So it produces the bright dots, okay, in the middle of the this is the diffraction, okay, the effect of diffraction. So they produce the bright spot, okay, on the middle of it. Okay, so that is the diffraction of light. Okay, so we compare. So this is for the narrow slit and this is for the wider slit. Okay, you can see the size of the fringes, okay, at the middle is become smaller. So this one should be when the size of slit, the smaller the size of slit. So this is the relationship. The smaller the size of the slit, the wider, right? The fringes, okay, at the middle. Okay, so this is for the green one. So you can see when it increase 0.02 until 0.16, here the middle fringes, okay, the middle fringes, it become smaller. Okay, now it says the experiment is repeated by using a pinhole camera. Okay, so what happened to the light as passes through the pinhole? Of course, the diffraction will occur. So the light will be diffracted. Okay, so now we have to study the application of diffraction of water, light, and sound wave in our daily life. Okay, so the first one for the water wave, so we build a barrier. Okay, so we already know when the water wave travels, okay, to the beach, right, to the beach, near to the beach, so they will bring the energy. So the energy is a high energy. So we must do something so the energy will be decreased. Okay, when you enter the beach. Okay, so this one is, see, if you want to build a house, okay, near the beach, so they make a barrier there. So when the wave pass through the barrier, okay, when the wave pass through the barrier, the wave will be spread out. So means when the wave is spread out, the energy also will be spreading out at the same time. So when the energy is spread out, the amplitude will be decreased. Okay, so that's why they have to make the a barrier, a pair of barrier. Okay. Okay, so it says have to compare the size of the amplitude of the C wave, okay, before and after passing through the wall opening. Of course, the amplitude will be decreased. Okay, since the water wave will be spread out. Okay, and then by relating the size of the wave with the energy, explain how the erosions affect the beach around the housing area can be reduced by the barrier. So when you build a barrier with a small opening, so that diffraction can occur. So we build a barrier that have the small opening. So when it enter, the diffraction can occur. So you already know the smaller the size of the gap, the diffraction is more obvious. So we build a smaller gap there. Okay, and then the next one, the energy of the wave is spread out to larger area after passing through the gap and will be reduced. So there will be spread out. Okay, the water will be spread out means the energy also will be spread out to the wider area. So the amplitude will be decreased. Right. So this is the explanation. Okay, how does the diffraction can help with the erosion at the beach. Okay, and the next one, the diffraction of waterway produce calm of water region, suitable for the docking of ships and water recreational activities. So they put the gap here, so when the water enters, so diffraction will occur. So now the water will be spread out, in this way. Means the energy will be spread out. So here the energy will be decreased, amplitude decrease. So here at this part, the water will be more calm. Okay. All right. For this one, it says an audio frequency generator, right, is connected to the speaker and placed near the corner of a wall. So there are 3 students that are standing around the next corner. So there are A, B, and C. So the generator can and the speaker produce sound at the same speed but different frequency. Okay, and the next one is said when a high frequency sound is generated, only student C can hear clearly. But when they use the low frequency sound, so all the 3 students can hear clearly. So explain the situation. So now we go back to the formula. So this one actually they use the formula that I just explained just now. F is equals to V over lambda. Okay, so now let's say the frequency is higher. Okay, so when the frequency is higher, the lambda will be lower. Okay, so means the wavelength will be decreased. So when the wavelength decrease, we already know the effect. The 2 factors that affecting the diffraction is the wavelength and also the size of slit, right? So here the wavelength is decreasing. So when the wavelength is decreasing, of course the sound will be less diffracted. Okay, you want to increase the diffraction, you have to increase the wavelength. But now the wavelength is decreased. So of course the effect of diffraction here also will be decreased. So mean there will be less sound that will be diffracted. So that's why only C can hear. Only student C can hear the sound because the wavelength is smaller. Okay, now we change the frequency to lower frequency. So when the frequency is lower, what will happen to the wavelength? The wavelength will be increased. And we already know the higher the wavelength, the more obvious the diffraction. So means there will be more of the sound that will be diffracted. Okay, so here that's why the student A, B, and C can hear when they use the low frequency, because low frequency will produce the high wavelength. Okay, while the high frequency will produce the lower wavelength or the smaller wavelength, so it will not easy for it to be diffract. Okay, so that's the reason. Okay, so this is the explanation that I just explained just now. So the frequency is inversely proportional to the wavelength. So high frequency, short lambda, short wavelength. So it's difficult to diffract. Only C can hear clearly. Okay, sound easily diffracted with the long lambda or long wavelength. So all three students hear clearly. Okay. Can you understand for this part? Why only students C can hear when we use the high frequency? Is it okay?
Yes, sir.
All right. Okay. Okay, the next part is the owls are able to communicate, okay, across long distance in the forest because they have a long wavelength hoods. Okay, so explain. So the sound of the owls will diffract through the space between trees in the forest. So the longer the wavelength of the hoods, also easier to be diffracted. So mean it produces the longer wavelength. So when the wavelength pass through the space between the trees, so the diffraction will occur. Right? And the infrasonic wave produced by elephants have long wavelength to facilitate long distance communication between elephants. Alright, so this is the function, okay, in the animals. Okay, and for the diffraction of light waves can produce hologram, which are used as safety features on bank cards such as debit card and credit card. Okay, so this is also they use a diffraction of light. Okay. All right. So we still have 4 minutes. So we try to answer this one first. Maybe this is the last, and then we stop and we continue on tomorrow. Okay. Okay. 2 more. You accidentally click wrong answer. So what is your answer actually? C. Okay. Okay, which of the four diagram below shows the water wave which pass through a small gap? So small gap, of course, it will produce the circular wave. So the answer should be C. Okay, very good. Oh, your answer is C just now, right? Abi, why A? A is not circular. Small gap must be circular. Okay, if the wide gap, then it produce like this. This is for the wide gap. Alright. Okay, so I will stop until now. I see you on tomorrow, 12:30, right?
Yes, sir.
Okay, so see you tomorrow. Take care, everyone. Okay.
Thank you,
So,
sir.
welcome.
Thank you,
Teacher.
Welcome.
Teacher, tingnan
Okay.
Tomorrow go eh?
Got 12:30, the extra class. We discuss on the group.
On the presentation only.
No, we do a present because we only have 2 people left. So after the presentation, we continue with this one.
Okay.
Okay.
Okay, bye.
Bye.